Let's imagine we're waking up to a cloudy sky, checking the visual app, and found the PM 2.5 levels over 100. This has become a common experience for many people in Bangkok. But what about other parts of Thailand? Are the places like Tha Sala and Trang, are they facing the same problems as us? With climate change disrupting weather patterns, shifts in rainfall, air pollution and temperature could be affecting air quality, agriculture, and daily life. This led us explore these environmental factors, uncovering their impact, and seeking solutions for a healthier and more sustainable future.
Methods: Globe Observer app and Globe.globe website developed through the Globe program with NASA. The instrument used by the researcher in collecting data on precipitation patterns, temperature variability, and indirectly supporting PM 2.5 and CO2. And this is how to use application. 1. Choose Cloud app. 2. Choose New Cloud Observation. 3 and 4. Observe the sky, the clouds, and don't forget the cloud in the edge of the frame. For the study site, the sites that were studied are located in Trang Province, Mueang District, and Nakhon Si Thammarat Province, Tha Sala District, which is here and here. Both are the southern part of Thailand along the Malay Peninsula, which are surrounded by eastern Gulf of Thailand. These two provinces may be located in the same region but are very different. Trang has coastal landscape, while Nakhon Si Thammarat has mountainous and forested landscape.
And what kind of tools do we use? Let's take a look. The data from David weathering sensors were exported from the weathering.com website. Airlink 1, 2, and 3 was installed in Nakhon Si Thammarat, which collects data for PMs. CX001.3 was installed in Nakhon Si Thammarat, which collects data for rain and temperature. David weathering NIAWL Live was installed in Trang to collect data for rain and temperature, and CO2 IoT sensors was installed in Trang to collect data of CO2. These devices forecast real-time data for 3 days, from the 24th to the 26th of February 2025, as shown in Figure 2. Data from David weathering was collected in Nakhon Si Thammarat Province and Trang Province for 3 days to compare weather conditions. Readings were saved every 15 minutes, while the website recorded data every hour. The study tested how accurate and reliable the system was in different places.
For now, let's move to the results and discussion. Now we have the graph. As you can see, it's a scatter plot showing the relationship between rain versus temperature. Yeah, and we have two graphs, which the first one is Tha Sala District. Yeah, located in Nakhon Si Thammarat. And the second one is Trang Province. Now, the x-axis shows us the rain in millimeters, and the y-axis shows us the temperature in degrees Celsius. So we can summarize these two graphs as the data shows a weak to moderate inverse relationship between rainfall and temperatures in Trang and Tha Sala. Higher rainfall tends to lower temperature, and while the dry conditions increase temperatures. Yeah, to clarify, it's like easier. Let's think about when we're at home and it's raining. We felt a bit cooler, right? Yeah, it's the same thing. When it's raining, it is mean higher rainfall. It's cooler. It's get cooler. That means it's lower temperature. The higher rainfall and the lower temperature, it's inverse. Yeah. So now let's move to the second graph, or the second scatter plot. Yeah. Now this graph shows us the relationship between temperature versus PM 2.5. Yeah, which is in Tasala district. As I said, it's located in Nakhon Tamarat province. Now the x-axis has changed. Now it's the PM 2.5 in micrograms per cubic meter. And the y-axis is still the same. It's temperature in degrees Celsius. Now we can clarify this graph because this graph shows a very weak negative relationship between PM 2.5 and the temperature. This suggests other factors like weather patterns and emissions play a bigger role in air quality. So now let's move to the third graph, which shows us about carbon dioxide level. And this data collected in Trang province. Yeah, and the x-axis shows us the date and time that we had that data, and the y-axis shows us the carbon dioxide level in parts per million. The graph reveals our general upward trend in CO2 levels, suggesting influences from seasonal activities such as agricultural burning, industrial emissions, or vehicular traffic, common in tropical regions like southern of Thailand. Yes, we all know, we go out, we found carbon dioxide. We found from the smoke from the car, or many more reasons. Yeah, so that's why we got that amount of CO2 level in the graph.
For the next graph, or a scatter plot, it's showing the relationship between rain and CO2 in the Trang province. For the x-axis, it's showing rain in millimeters, and for the y-axis, it's showing CO2 in the level of CO2, in ppm. This graph suggests that if the rainfall increases, the level of CO2 tends to decrease slightly. Let's say if there's no rain at all, the CO2 level is high. But if there's a lot of rain, or if it's raining, the CO2 level is pretty low. Because, do you wonder why? It's because when the rain falls, it's water, right? The water dissolves the CO2. That's why the level of the CO2 is pretty low. Continuing to the next graph, which is temperature and PM 2.5 located in Nakhon Tamarat. For the x-axis is the temperature in degrees Celsius, and for the y-axis is the PM 2.5 measured in micrograms per cubic meters. This graph suggests that if the PM 2.5 concentrations increase, the temperature slightly decreases. But keep in mind that the temperature does not directly or indirectly affect the PM 2.5. We have to look to other factors too, such as rainfall, etc., etc. For the last graph, which is PM 2.5 and rain. For the x-axis, it's rain in millimeters, and the y-axis is PM 2.5 measured in micrograms per cubic meters. This graph, you can see that it's pretty similar to the CO2 graph that I talked about before, because both PM 2.5 and carbon dioxide are pollutants in the air or particles in the air. When the rain falls, it dissolves, and we can see it's the negative correlation, and the graph is pretty similar. To conclude, from all the data and correlation that we found in those 6 graphs, we can see that rainfall in southern Thailand plays a key role in reducing PM2.5 and CO2 levels, and also cooling the temperatures too. But how does this data benefit us? Well, right now, we know that in the dry period, the pollution and heat risks rise, which emphasize the needs for better monitoring, emission control, and sustainable practices. Now, the regional corporation know what to do from the data that we integrate, like weather patterns, pollution sources. So this data is pretty important to plan what we should do in the future.
We thank Associate Professor Dr. Kisanadet Jaran Suthasini and Associate Professor Dr. Malika Jaran Suthasini, staff of Walayalak University, for helping with experimental design, fieldwork, data analysis, and manuscript preparation. Samsen Vichai School and Walayalak University partly supported this work.